Friends, welcome back again. Now, to go in detail about the order of reaction, I have taken some examples from textbook to understand the concept in detail. Let us see. I have written three equations. So, first equation is 2NO reacting with 1O2 to form 2NO2. Second is 2H2O2 decomposing to form 2H2O plus O2. And third is 2NO reacting with 2H2 to form 2N2 plus 2H2. Now, already experiments are performed for this, and according to the experiments, for the first reaction, rate law equation is rate is equal to K concentration of NO to the power 2 concentration of O2 to the power 1. In this equation, we can see that the order of NO is 2 and the order of O2 is 1. 2 plus 1, overall order of reaction is 3. For the second, rate is equal to K concentration of H2 to the power 1. And for third, rate is equal to K concentration of NO to the power 2 concentration of H2 to the power 1. In this you can see that, so here coefficient of NO is 2, order is 2. Coefficient of O2 is 1, order is 1. Coefficient of H2O2 is 2, but order is 1. Coefficient of NO is 2, order is 2. Coefficient of H2 is 2, but the order is 1. So order is not same like coefficient. Order is not coefficient. Order is determined experimentally. So don't write coefficients as order. In some cases, coefficients order can be same like coefficient, but friends, remember this thing, order is not coefficient. This is the coincident where the coefficient is order of the reaction is same like coefficient. Order of the reaction is same like coefficient, but this is only the coincident. Always remember, order of reaction is not coefficient. So this was the thing which I was expecting to share with you. Now, as I told you, order can be determined experimentally. But how? Let us see this experiment. For that, I have written one example from textbook to understand this thing. Reaction of A giving product B. In the first case, two experiments are performed with respect to the concentration of reactant A. What is that experiment? See here, concentration of reactant is 0.10. I have not written units because units will create slight confusion here. So I have written only values. So the concentration of reactant A is 0.10 in first experiment and rate is 3.0 into 10 raised to minus 3. Now going to the second experiment, what has changed? The value of reactant A is changed from 0.10 to 0.20. This means that concentration of reactant is doubled. Concentration of reactant A is doubled. Concentration of reactant A increases 2 times. Concentration of reactant A is increased 2 times. Let us see what is the effect on the rate of reaction by doubling the concentration. Initially the rate was 3.0 into 10 raised to minus 3. What is the rate now? 12.0 into 10 raised to minus 3. So going from 3 to 12. Rate increases how many times? Rate increases 4 times. 3 into 4, 12. So rate increases how many times? 4 times. So 3 into 4, 12. So by doubling the concentration, rate increases 4 times. What will be the order of reaction? Let us solve. For this, how you will write the equation? Rate is equal to concentration of reactant A increases 2 times. What is the change in the rate? Rate increases 4 times. So 2 is equal to 4. So what will be the power? 2 raised to 2. 2 raised to 2 is 4. So order of this reaction is 2. Order of this reaction is 2. So how we determine the order of reaction? By experiment. To understand the concept in detail, let us go for second experiment. This is the reaction of A plus B giving product B. Two reactants are there. Now friends, here you have to solve the problem very precisely because two reactants are given. Let us see the experiment. How many experiments are performed? 1, 2, 3. 3 experiments are performed. So there will be 3 rates. And according to this, you have to find out the order of reaction. So friends, can you determine the order of reaction by looking at these equations? Yes, you can determine. Let us see. Now see the concentration of reactant A. So it is 0.10 in first case, 0.10 in second case. So going from first experiment to second experiment, concentration of reactant A is constant. Now going from first experiment to third experiment, concentration of reactant A is doubled. So it is 0.10 to 0.20. Let us consider the B. So initial concentration is 0.10 and going from first to second experiment it is 0.20. So it is doubled. It is doubled. Now to determine the order of reaction of one reactant, either order with respect to A or order with respect to B, for that you have to consider one reactant as a constant. One reactant as a constant. The concentration of one reactant should be taken as a constant, and other concentration of other reactant should be changed. So see here, in first case, first 2 experiment, the concentration of reactant A is constant. It means that there is no effect of reactant A on the rate of reaction. So only B will affect the rate. See the concentration of B. It is changing from 0.10 to 0.20. So we are doubling the concentration. A is constant. So B changed. So there is effect of change of concentration of B with respect to there is change of rate with respect to change of concentration of B. A is not affecting, A is constant. So concentration is doubled. Let us see what is the effect on the rate. So initially rate is 2 into 10 raised to minus 3. It is now 4 into 10 raised to minus 3. So going from 2 to 4. So rate is doubled. So can we predict the order? Yes, we can predict the order of reaction. We can predict the order of reaction. How you will write? So rate is equal to concentration of reactant B is doubled. Rate increases 2 times. So what will be the value of power? It will be 1. 2 raised to 1 will be 2. So order with respect to B is 1. Determine experimentally. So with respect to B, order is 1. Let us find the order of A. For that, the concentration of A will change and concentration of B will remain as it is. You have to see where concentration of A is changed. So from 0.10 to 0.10 constant, 0.10 to 0.20 change. So from 0.10 to 0.20 it is changing. How it is changing? Concentration increases 2 times. Definitely B will be constant. See, in first experiment B is 0.10 and in the second experiment B is third experiment B is 0.10. So concentration of B is constant. So B is not affecting the rate of reaction. So which one is affecting rate of reaction? A. So 0.10 to 0.20. So concentration increases 2 times. So you have to see going from 0.10 to 0.20, what is the change in the rate? 2 to 8. So rate increases how many times? Rate increases 4 times. Rate increases 4 times. Going from 2 to 8, rate increases 4 times. What is the change in the concentration? 2 times. So let us find out rate of order of with respect to A. Concentration increases 2 times, rate increases 4 times. So 2 is equal to 4. So here will be 2. So order with respect to A is 2. So order with respect to A is 2. Order with respect to B is 2. So 2 plus 1, order will be 3. Overall order will be 3. So in this way we can determine the order of reaction experimentally. So order of reaction is experimentally determined quantity. Friends, order can be 1, order can be 2, order can be 3, reaction can be nth order. So this can be determined by observing the effect of concentration on the rate of reaction. Friends, as I discussed, if there is concentration and there is no change in the rate of reaction, it means that the order is 0. If rate is not changing, so order will be 0. And if rate is changing, rate is increasing, order will be positive. order will be positive. And if rate decreases by changing the concentration, by increasing the concentration, if rate decreases, the order will be negative. Order will be negative. So if rate remains as it is by changing the concentration, order is 0. Concentration increases, rate also increases. Concentration increase, rate also increase, order will be positive. And if concentration is increased and rate is decreased, order will be negative. If concentration decreases, rate also decreases, this means order is positive. Decrease in concentration, decrease in rate, positive. Increase in concentration, increase in rate, positive. But increase in concentration of reactant decreases the rate of reaction, order will be negative. And no change in the rate of reaction. If the concentration is changed, means order is 0. So order can be positive, can be negative, order can be 0, order can be fractional also. And how it is determined? Experimentally determined. Friends, so I hope that you have understood the order of reaction properly. And in next video, I am going to differentiate order and molecularity. Thank you.